All right, here is Learning Check 4.05. There are two ones today. The first one is, what is the percent composition of ammonium sulfate? So go ahead and hit pause. And welcome back. Percent composition. First, we got to figure out who ammonium sulfate is. Ammonium is NH4 plus 1. It's one of the few polyatomics that's positive, or a cation. Sulfate SO4 minus 2. I have to crisscross, so polys need parentheses. The 2 goes over here. Oops, this probably needs a parenthesis too. There we go. We don't want to make it 42, and we don't want to cancel off the 4. So those parentheses are like a force field around there. You don't touch anything on the inside. Rewrite, NH4 has 2. SO4, since it has 1, I don't need to write the parentheses there. Okay, so what does that actually mean? If we're distributing, that means that I'm going to have 8 hydrogens and 2 nitrogens. So I have 2 nitrogens total, 8 hydrogens total, 1 sulfur total, 4 oxygens total. So what is the mass of 2 nitrogens? 2 times 14.01, 28.02 is the mass of 2 nitrogens. 8 hydrogens, 8 times 1.01, 8.08 is the mass of 8 hydrogens. There's 1 sulfur at 32.06, so 32.06 is the total mass of all the sulfurs. There are 4 oxygens at 16.00, so there is 64.00 total mass, okay, of just the oxygens. What's the total mass of everybody? Let's add up those numbers. 28.02 plus 8.08 plus 32.06 plus 64 gives you a total of 132.16. That's the total mass, or that would be the molar mass of ammonium sulfate. There's 132.16 grams in 1 mole of NH4 to SO4. Okay. So now we can use that to find our percent composition. Part over whole times 100% is our equation that you should have written down. So 28.02 over 132.16 times 100% gives me 28.02 divided by 132.16 times 100%, 21.2% nitrogen. Okay, so that's our answer for nitrogen. All right, how about the second guy? 8.08 divided by 132.16 times 100%. 8.08 divided by 132.16 gives me 6.1% hydrogen. And on these, just whatever the question says, if it says complete it to the nearest whole number, or complete it to the first decimal place or the second decimal place, just follow whatever answer it says there. All right, next guy. There are 32.06 grams of sulfur in 132.16 grams of sulfur. 32.06 divided by 132.16. Okay. 24.3% sulfur. And oxygen. So oxygen, I could do that same process, or I could just say 21.2 plus 6.1 plus 24.3 is 51.6. So the remaining 48.4% has to be oxygen. Okay, so now I have broken down the percentages of each. Notice if I tried to just say 2 nitrogens over 15 atoms, I would not be getting these same numbers, because this is a weighted average. It's based on their different masses. So make sure you're finding the mass of each one and then putting it over the total mass or the molar mass of the compound. So that is the percent composition. Our second one is an empirical formula and molecular formula. So you're going to do both parts at one. Go ahead and hit pause. And let's get started. All right, empirical formula. Okay. Carbon has 8.81% carbon. And chlorine, it has 91.19% of chlorine. Okay. So now the first thing we have to do is we have to change the percentages into grams. So if I assume that it's 100% and I assume that it's 100 grams, it would be 8.81 grams and 91.19 grams. Now, sometimes it's just going to give you grams in the problem as you're known, in which case you get to skip this first step. It's already been converted to grams. Second step, convert to moles. How do we go from grams to moles? We use their molar masses. Okay. Now you can totally rewrite out your known equals question mark unknown, but hopefully at this point you're getting comfortable enough with that. So for empirical formula only, not for stoic or mole conversions, you can just divide by the mass of the element. Okay, so carbon's 12.01 and chlorine's 35.45. Okay, so now our answer is going to be in moles. 8.81 divided by 12.01 is 0.73356. And 91.19 divided by 35.45 is 2.5724. Okay, and just keep these so many numbers out there. If you see you're going to have 3 or 4 sig figs in the answer, keep 4 or 5 when you go on. And that's just your best method to make sure you do carry enough over. So now it's in moles because we converted from grams to moles. So now we got to minimize this so we have a better ratio. So find who has less. That's 0.7335, and you divide it by itself so that we can change that into a nice ratio quantity of 1. And what you do to one thing, you have to do to the other. Don't divide the other one by 2.57. You got to divide it by the same divisor you did the first time. Okay. 0.73356. When I divide those, I get 3.51. Okay, so now we're getting really close. However, we don't want to have halves in our relationship. So I want to get rid of that half. Get rid of a half, you multiply by its reciprocal. So I want to multiply by 2. And again, what I do to one thing, I do to something else. So I end up with 2 carbons at the end and 7 chlorines at the end. And you can round to the nearest one or the nearest whole number. But don't round to the nearest whole number when you're here because that's too far away. So do the multiplying and then round. You'll only ever have to multiply one time. Okay, so what this tells me is that there's 2 carbons and there's 7 chlorines in this. Dicarbon septachloride would be its name. Because remember that di, the 2 goes with the carbon. The 7 goes with the chlorine. So that would be its covalent name. How do I know it's covalent? Because both of those guys are nonmetals. 2 nonmetals gives you a covalent bond. All right, so let me figure out C2Cl7. What is its molar mass? 12.01 times 2 plus 7 times 35.46, or 45, sorry. And what is that going to give us? 272.17 is the empirical formula's molar mass. Okay. Now we got to find the molecular formula's molar mass. So how do we do that? We need to know our multiplier. Okay. To find the multiplier, we take the molecular formula's molar mass divided by the empirical formula's molar mass. Molecular formula's molar mass, 1362.5. Empirical formula's molar mass, 272.17. 1362.5 divided by 272.17. And my multiplier is 5. For this one, always just round to the nearest whole number. So my multiplier is 5. So I take each of these numbers. 2 times 5 is 10. 7 times 5 is 35. So my molecular formula is that. And you could always go back and double check it. 10 times 12.01 plus 35 times 35.45 is going to give you your molecular molar mass. So always use that as your double check. Again, you're going to turn in your work for this learning check and then one sentence about what you learned or one sentence about specifically what is still causing you problems. Have a good day.